Hello everyone. So let's see this example. In this example, we have two different processes available, process P1 and P2, and we have two different registers R1 and R2 as a resource. Process register R1 is allocated to process P1. If you see the edge direction of register R1, it is from R1 to process P1. Then it means it is allocated to process P1. Similarly, if you see the direction of edge of register R2 to process P2, it means register R2 is allocated to process P2. Okay, so this is the allocation edge, assigning edge, or you can say it is the allocated to particular processes. This particular resource is allocated to the different process. Now coming to the request edge, process P2 is requesting register R1, okay, because the direction of edge is from process P2 to register R1. Similarly, process P1 is requesting register R2, okay, because here direction is from P1 to R2, okay, and this is single instance resource graph. You can call it as a single instance resource graph. Why? Because only one instance of R1 and R2 are present in this graph. Okay. Now I want to check whether this graph, this particular two processes and these two resources, whether it caused a deadlock problem or not. For that purpose, I want to draw the tabular form by using this resource allocation graph. So in tabular form, we already see in Banker's algorithm, there are two columns. One column is allocation, which define the particular resource is allocated to the some processes, and there is one other column called request column or need column. Okay, so you can call it as a request or you can call it as a need. The concept is similar. In allocation, we have two different resources R1 and R2, and in request also we have two resources R1 and R2. And coming to the row section, there are total two processes P1 and P2. So P1 cover the first row and P2 cover the second row. Now for allocation, we need to go to the resource vertex. If the direction of edge is from a particular resource to the process, then it means this resource is allocated to the this process. So here resource R1, register R1 is allocated to process P1. So I will go to the allocation column and see the column R1. R1 is allocated to P1. So I will fill it as value 1 and the other value will be 0. Similarly, for process P2, if you see register R2, the direction of edge is from R2 to P2. That means R2 is allocated to process P2. So R2 is allocated to process P2 means here the value is 1 and here the value is 0. Got it? Okay. Now go back to the request column. For filling the request values, we need to go to the process vertex. In process vertex, process P1 is requesting resource R2 or register R2. So here in P1 row, register R2 value is 1 and R1 value is 0. And coming to the process P2 is requesting register R1. So go back to the process P2 row and in R1 column fill the value as 1 and the other value will be 0. Now our table is completed. The next step is we need to find the availability. So currently how many instance of particular resource are available or not. So here both the resource R1 and R2 are single instance resource, and these resources are already allocated to the process P1 and process P2. So currently there are no available resources, so the value will be 0 and 0. So using this value 0 0, can we satisfy any request of the two given processes, process P1 and P2? If you see the request column, here process P1 need one instance of R2, while process P2 need one instance of R1, and but we do not have any value, we do not have any instance of R1 and R2, so we cannot satisfy both the requests. So P1 request is not satisfied as well as P2 request is not satisfied. It means this particular graph, this resource allocation graph, is showing that it is present in deadlock, or it causing deadlock problem. So here one important point you have to be noted: in single instance resource graph, if there is any cycle present inside the graph, then it means a deadlock problem is present. So cycle, you maybe note down here, cycle is necessary and sufficient condition for detecting deadlock. Okay, so this point is very important, and most of the times questions are directly asked based on this point, so you have to remember this point somehow. Okay, this is single instance resource graph. In the next video we will see multi-instance resource graph.